You're beautiful. All right, what's up? Today we're gonna be playing The Binding of Isaac: Repentance Plus Beta again. This is the 10th episode, I think. 10th episode, and today I'm gonna be playing Lilith, Tainted Lilith, because I want to. We're going for the final fucking thing, whatever. I don't know. Okay, yeah, but what are we gonna talk about this video? Okay. For this video, I want to talk about how to learn quantum mechanics. All right. Like I said in the last episode, I was if you're watching, um, comment down below if you're watching every single episode. Comment down below. But if you're not, it's okay. You don't really need to watch the last episode to understand this episode. Because this episode is completely separate from the last episode. But yeah, so if you want to learn quantum mechanics, first you should probably learn what came before quantum mechanics. So, learning like classical mechanics, I think would be pretty important. So, you don't have to go too in depth, but maybe just knowing like Newton's like three laws of motion would be pretty good. Um, and just have like a sort of some kind of sense for physics and like the current landscape or like the history of physics too, or like the historical uh kind of like formulations of physics, which include like classical mechanics and then electromagnetism. Um, but if you want to learn quantum mechanics, I'm assuming that you probably already know those prerequisites. So cool. Now that you know those prerequisites, you want to learn quantum mechanics. Okay. So what I recommend is for you to really focus on like the basics at first. So understanding like probability, and I mean also have some kind of prerequisite knowledge of like statistics. I think would be important. Just because quantum mechanics, like at least the mathematics of quantum mechanics, really just comes down to like probability, and then or like the most like the what is it called, like the foundation, I guess. It's like statistics and probability. So knowing statistics and like what a probability function kind of looks like in quantum mechanics would be pretty important. uh yeah, like yeah, so here's like a bit of knowledge, I guess. Like a wave function in quantum mechanics is just like telling you the probability that, or like the x input is whatever input you want to give it, and then the y is uh some probability that you'll find it at that given input, basically, you know. Let's take one shop item for free. Okay. But yeah, I recommend going with the textbook with like the cat in front of it, like the red one, I think it is. I think that one's pretty good. And if you ever want to learn electromagnetism as well, I recommend that book as well because it's pretty good. Um, and yeah, should I go for that? I can't. But yeah, yeah. So now if you actually like want to, maybe I could just teach you some quantum mechanics now, I guess. So, quantum mechanics is basically classical mechanics. So understanding how objects move and the basic like structure of objects. That's what like classical mechanics is, at a basic level, I guess. Like that's what physics is. I mean, you're trying to understand like the world and how it behaves. So that has to do with like how stuff moves and also the composition of things. Sort of like chemistry, but uh, more so like how it interacts with one another and stuff like that. I guess I don't know. But yeah, so uh, yeah, quantum mechanics came from classical mechanics, but it differentiates itself from classical mechanics because instead of stuff being continuous in like a way, you know, continuous in the sense that um, objects in space can be literally anywhere, or that um, like the output of some object can be anywhere or can be anything. Um, and when I say anything, I mean in like um, oh, in the sense that in like some set of like numbers or something, it's like the real numbers instead of like some discrete set. So in classical mechanics, the set of numbers that is used in like the domain and like the codomain of like functions is the real numbers. Um, for like this for this analogy, but in quantum mechanics, the set becomes like um, not the real numbers, you know. So that kind of implies that it isn't complete, you know, or that fuck you, or that like you know it just isn't. Yeah, I mean I already said like complete, but I hope you know what I'm trying to say. If you don't, you can comment down below. But yeah, so it comes from classical mechanics, but it differentiates itself because it's discrete. Why is it discrete? Because it kind of comes from like a thermodynamic kind of way of thinking, or that's how it kind of like began. Specifically, like if you know any like history, I guess, of like physics, like the ultraviolet catastrophe or something. Um, that's where supposedly quantum mechanics like was born, and this is because like in the past or something, people kind of or like if you have like some object that's black, um, then um, the temperature of that object um, uh, like perfectly correlates itself with the light that's emitted from the object. So if you start with like a black out object and you heat it up, then it'll turn like red, you know, and then at some point it'll turn like like blue and then like white, you know, because it gets so hot. Uh, but if you what's it called? If you like increase the temperature indefinitely, you know, then you would get these wavelengths of light that like are basically like or like the experiments for that thing didn't match what the like theory was, you know. So we expected that as you increase the temperature, um, the wavelength of light should change, and it should change like as in like get greater, I guess. But it wasn't doing that. So people said like, "Yo, what the fuck's up?" And we didn't know what was up for like a very long time. Um, until I think like I don't know who it was. Okay, to be honest, but um, but like someone did come along at some point and said that if we instead of thinking of like the um the emission of light as being something continuous, you thought of it as it being something um like discrete. So instead of like light always being like emitted at these like at these continuous wavelengths of like light, so if you increase the temperature by like zero point 0.1, it would proportionally like increase the wavelength of emitted light by say like zero point 0.1 divided by 2 and so on. So that relationship would be like a divided by 2 relationship, you know, or whatever. uh, but yeah, instead of that, we said imagine that as you increase the temperature of this black object, uh, the emitted light that was actually emitted is only emitted at these sort of like packets of these packets of light for specific increases in temperature. So as you increase the energy that you put into like the system, it would only emit light at, or it would only emit a different frequency, or yeah, a different frequency slash wavelength, frequency and wavelength for the purpose of me talking right now are like the same things. Um, so yeah, but as you increase the um, the fucking temperature, um, it could only like change its wavelength of light, depending like at a certain threshold of energy that you put in. So so that's how quantum mechanics was born, and and this was kind of like this is literally how nature works. So it isn't the fact that um that like light itself um kind of like changes itself for every single um like change in like energy that like you put in, or something like that. It's quite literally like the fact that stuff is like stuff has memory in some way, where where it just kind of knows that it should emit this different frequency of light um, at this specific threshold of energy, which is really unique. But yeah, yeah, you could think of it like it has like some sort of memory, because that is kind of how it works. Um, uh, but it's not like thinking like, oh hey, I'm gonna only emit this frequency of light um, when when this specific amount of energy is added into like the system. Um, uh, but that's literally, I mean it kind of is like that. But yeah, I don't know. Hopefully you understand what I'm trying to say. This is a good item, and we're gonna do this too because I want to live. But yeah. Ooh, I think I kind of want that item too. So yeah, what's some cool things in quantum mechanics that you can do now, I guess, or some facts of like from quantum mechanics? Um, well, um, if you have these like quanta of like when I say quanta, I just mean like this little packet of um of like energy slash light, because um that's a good item. I will do this. And okay, yeah, so if you have these like packets of light and stuff, I'm trying to explain what superposition is, basically. And honestly, I never really learned. So, okay, full transparency, why I'm trying to explain quantum mechanics to you, um, and why I think I'm like a decent person to explain this stuff to, or explain this stuff, is because I got a degree in physics, and if you study physics today, like a big part of physics is quantum mechanics. So although like you will never actually encounter quantum mechanics in your life, like in your daily life, uh, people still do kind of have to learn it if you want to understand physics. And I already explained what physics is, so you shouldn't have to question that now. But yeah. Um, so I think we all kind of know the concept of superposition, um, which is like, uh, um, basically, yeah, okay, yeah, like these objects in quantum in nature, I guess, occupy these different states. Um, these states just being like um like facts about their characteristics of like being, So when I say that, characteristics of being, I mean how fast are they moving, where in space are they, um like depending like on time, like where in space are they, and so on, So that's like, or like also like their momentum is like one state, I believe. I think this is shit. I think this is what people like refer to states as, I think. I'm pretty sure. But yeah. Yeah, stuff has different states, and Superposition is simply just like just the um just the phenomenon where an object is in two states at once, functionally speaking. I say functionally because like I can't be in two places at once, um or it's I don't think it's, yeah, I mean, yeah, it's just the fact that, you know what, like, yeah, it's just like, I don't know if I'm quite uh what's the word, like, eligible to teach this right now, because I haven't really studied it in a very long time, precisely like 2 years ago or something. But I did pass my class to to what's it called, um to like, know this stuff, you know, so I do know this stuff, just a long time ago, I guess. Yeah, but yeah, superposition is just occupying two states at once. Yeah, and that's basically how you get like quantum computing as well. Quantum like computing is just like normal computing, except like the states that um like the bits can be in are anything your heart desires, but not really. But yeah, so okay, what else in quantum mechanics? So yeah, if you want to learn quantum mechanics, this is how I learned it basically. Like, you have these states. These states are represented like mathematically by these things called like like bras and kets. Um, it's like Dirac notation, I think, or something. It literally does not matter. I'm gonna get the effect taken for me anyways. Um, oh wow, these suck. These freaking suck, man. I guess I take this, but I don't really like it. Okay, yeah, cool. So now you know, kind of, you should know basically um, the basics of quantum mechanics now, and how to represent um, different objects, I guess, or something. Schrodinger's equation. What is Schrodinger's equation? Schrodinger's equation, to the best of my knowledge, is um, is a function that takes in a position, or if you're talking about the time-dependent Schrodinger equation, you um, uh, you take in two inputs, space and time, and you basically just output like anything your kind of heart desires, basically. I'm pretty sure, except usually it's just also just space and like where in space it's transformed. Um, yeah. Um, yeah. If you also want to learn quantum mechanics, you'll probably encounter these like one-dimensional, two-dimensional, like energy well problems. Um, did I ever fucking understand that shit? I don't fucking know, man. But yeah, like, my headset's gonna die soon. Fuck. The consumption of energy. But yeah, so what was I talking about? Yeah, so you'll probably encounter like these problems about like a particle in like a energy wall, in like an energy well. I mean, not a wall. And those are basically it's literally what it sounds like. It's just like a particle inside this like infinite uh like this like well of like infinite, like this well that has these walls of infinite energy that like, so like the particle can't escape or something, you know. So, and then you basically want to like uh like determine where like how like the particle evolves, and this is helpful for when you're talking about like the electrons in um like some atom. It's helpful because Clear rune. Spawns 1 rune on pickup. Alright. Show me some sugar. Platinum God? Oh, shit. I got Platinum God. Oh, shit. Wait, dude, I got Platinum God? What the helly? Wait, this is insane. Wait, guys. I know I'm talking about quantum mechanics and this foo-foo bullshit, but this is a huge moment in this game. I just got Platinum God. That basically means that I like completed the game like when it came out a long time ago, but like there's been a lot of expansion packs recently, so I haven't completed this version of the game. But that's crazy. I just got Platinum God. Oh my god. Oh my god. I can't believe it. That's actually insane. Wait, that's sick. Wait, damn. Okay. Wait, that's really sick. Where was I? Yeah, I was talking about something about like energy levels or something. Oh no, I was talking about like electrons in like an atom. Yeah, okay, yeah. If you have electrons in an atom, electrons are the things that emit the photons like at these like discrete energy like packets. When I say photons, I mean light. Photons are light. Yeah. And so yeah, if you want to understand like the behavior of these electrons in an atom, electrons in an atom are also, so we think of electrons as like these balls of like these balls of energy basically, right? The same way we think of photons, except electrons have mass, whereas photons are massless. So photons are more of like this like theoretical kind of I found pills, more of this like theoretical kind of framework of nature, where it's not anything we can really imagine. Like a photon, we can't really imagine a single photon, except that that's literally what light is. It's the same way like you don't think of light as having like mass, you know. Yeah. So yeah, if you want to think about electrons in an atom, this problem of like these energy wells are important because you can basically like the energy well is like a super simple kind of problem, right? But in physics, as you do a lot of times, you kind of like extrapolate like a super simple thing. Like this guy in my graduating class, he gave a speech about how he knows a lot about like springs, because springs basically like are a good way to kind of like model like nature in a simple way, or like in a way that we can understand, and then we can apply that simple like kind of framework to like basically like everything. So yeah, that's the same way for like this energy well. You'll never find like an atom or like, I mean like some object. And when I say object, I just mean like some particle or something, you know, some particle in like this wall of infinite energy. Except you could, I think, in like a lab, like pretty easily like come up with like some controlled experiment like that. But that's beside the point. Yeah, that's beside the point. Hopefully I win this game. By win, I mean just beat this. But yeah. Ooh, okay. Damn. Okay, yeah. So yeah, that's like a problem that you'll find in quantum mechanics. Oh wow, this is a sticky situation. Cool. Cool. Oh yeah, so yeah, yeah, you'll find that in nature a lot. Or you won't find that in nature, like the particle in like a well, thing. but it's a good way to explain nature and the world around us. So yeah, scapegoat. Um. So yeah. What else did I learn in quantum mechanics? Oh yeah. The electrons though in an atom are explained by the energy in a well thing, because an electron, instead of just being like just like some particle, can also be represented as like a wave, the same way light can be. Um, and why is this? It's because like the mass that like an electron actually possesses, although it's there, it's very like small. So like everything can be represented as a wave. Um, this is like just like an equation, like the de Broglie wave equation. I think it's what it's called, if you really wanted to know. And and an electron can be represented as a wave. And when you do like this like problem of a particle in a well, um, what you're really doing, I'm pretty sure, is you're just like, yeah, so you're finding like where like you're trying to represent or you're trying to find like a function. So um just using like the Schrodinger's like wave equation, you're trying to find that function um for like this particle, so that you can like understand like where in space, like how it transforms in this like space, um and like it'll go back and forth, and it'll have like stuff like it'll like have spots where like a standing wave, if you ever seen like a standing wave has like these like nodes, I think, or something like that. So yeah, hopefully one day I'll have like a really good like video or something, where I do explain something that I'm extremely knowledgeable in. So yeah. Um, Unidentified, but why not? So yeah, if you do like this like problem, you'll see like that how it transforms is um like uh this kind of like, oh wow, sticky. Oh wow. Come on, come on. Okay, nice. It basically just, I mean, I'm not too sure how it transforms, if I'm being honest, so I'm not gonna like bamboozle you or something. Oh shit. Oh, nice. Very nice. But I'm pretty sure that it has like these like spots where it has like constructed interference and stuff like that. Oh yeah, also a good way to understand like, or like a good application from nature. Nature just being like what we're in right now, like your body and everything, like the world around you. If you ever uh like see like a like a like a specific frequency of light, so maybe, so like if you don't already know, uh like light is just like what you're like everything that you see is light, and that's just like a very narrow like band of the light that does exist. There's a fuck ton of light, or like different kinds of light, and that's just because of like numbers. Like there's a lot of numbers that exist, so there's also a lot of light that exists. And when I say a lot, I just mean that like in the way that uh, that like we kind of process it, you know, in the way that we see it. Um, Nature doesn't think like that. There's a lot of light or something, you know. Just there's just a normal amount of light, if you want to think about it that way. Um, but yeah. Um, so, oh, I mean, I forgot what I was saying. Um, fucking. Oh shit. Oh shit. Okay, yeah. I actually just. I mean, I was talking about light, and then that. Uh, right. I don't know. Doesn't matter. Um, what I wanted to say. Oh yeah, if you look at the sun, and it's like about to like set. I've never actually seen this, and it's my dream, I guess, to see this one day in real life. But there's this chance that you can see like a green spot when like the sun lands, and that's not because if like when the sun uh like gets to this point in the sky, then that's when it shows like it being green. No, the sun is not green. Uh, except yeah, it's not green. Whatever. The green in the way that we talk about. Um, it's a lot of colors. It's just a shit ton of light. um, but uh, but like what? Yeah. So the reason why there's green light that comes out is, ooh, nice, is because like the sun, we can all agree, has a lot of energy, and ooh, Beelzebub. And when it's setting, all this energy is being concentrated basically at like the horizon, and instead of it like going like somewhere, it all gets concentrated into like a very like dense region of space. That the space I'm talking about being the horizon. Wait, have I done this? I guess I haven't. I feel like you know what? I think I just got this item before. Should probably do this. Okay, yeah. This is like one of the hardest fights in this game. I'm just kind of talking about some other shit. Oh, the heli? What just hit me? I'm just gonna do this. Okay, but yeah. I think quantum mechanics is really cool because it's not how we see the world, but it's how the world behaves. So, like, we have no obligation to understand the world, or like there's this quote by Richard Feynman, like there's no obligation for the world to like to be clear to us, and it's deadass just not clear at all, So I don't know. I think, but it's how the world works, and we don't know like why it behaves this way, and it just does. I don't know. So it's pretty cool. Um, I also think it's cool because quantum mechanics is not compatible with like general relativity. Uh, being because like quantum mechanics tries to like quantize everything that exists, and instead of like being like we can't quantize like so the crux of general relativity is that like space itself, uh, like literally space, like, and the curvature of space is how like gravity comes to be. Um, so if you want to like make quantum mechanics like compatible with make quantum mechanics compatible with general relativity, then you'd have to quantize space. But I think there's been a lot of efforts to do that, and it just has not worked. So tough luck, physicists. Um, but hopefully, I mean, I don't know what technologies would come from that. Like, I guess we could maybe like be able to, yeah, we'd be able to like kind of like make space work for us, basically. The same way like we like use magnets today to like make stuff move, like instead of like using our literal, well, using our literal like hands and fists. We just like use like magnets. So yeah. Yeah, this is like a weird run. I feel like I didn't get any good, like extremely good items or anything like that. But we did it, you know. Yeah. Um, yeah. If you want to, yeah. So how I basically learned quantum mechanics was that I learned the math first. So the math of quantum mechanics is like linear algebra, and I really just like for a full semester or two. I mean, like for like 2 semesters really. Like so, like for a full year, I learned linear algebra, and then I learned how to apply linear algebra in like this different way for quantum mechanics. And then you do that, and then uh, you learn, I guess. Oh wow, did I win? I don't know. I did beat him, yeah. Okay, cool. Yeah, you do that, and then you learn. Come on. Yeah, you learn how to apply the math, and then you learn these like kind of like how I like. I mean, I kind of view it as like numerical analysis in a way, where you could like, oh shit, you could apply like numerical analysis techniques to understand like it isn't like a pure science like quantum mechanics when like you have like a bunch of like particles in like a space. So how you oh shit so how you are able to like apply quantum mechanics and its findings to like more complex systems is that you kind of like estimate stuff a lot. So then my third semester, I guess, learning quantum mechanics was spent like using the like simple techniques that you learn like your first year or like first half year to a year learning, and then you dedicate that to learning more complex like techniques so that you can apply that to more complex systems. And you use like the hydrogen atom to like use like so the same way you use like the infinite well technique to apply it to like everything. You use like the hydrogen atom and it like itself to explain like other stuff. um I think I did a bad job doing that. uh I didn't prepare. I've just like been in the shower thinking about like what to talk about, and there's a lot of different stuff that like I didn't discuss, like the uncertainty principle. So that being like if you know like where a thing in space is, you don't know like how fast it's going or something, and you lose more information the more you know about one thing than another. And yeah, but that's how nature works. So if you enjoyed that, hit the smash button, hit the like button. I have to go to sleep. I think I actually am gonna hike that big mountain, the biggest peak in Ventura County, tomorrow or like today technically. And yeah, I'm gonna sell like this thing to this lady tomorrow, hopefully, if if she goes through with the deal. And yeah, stay loco and stay safe. Goodbye.